Haber's process for the manufacture of ammonia. Here we study Haber process under following points. Number 1, principle. Number 2, favorable conditions for high yield of ammonia. Number 3, method. 4th, precautions. And 5th, uses of ammonia. At first we discuss principle. On what principle Haber process is based? Very first, 1 volume of nitrogen and 3 volume of hydrogen reacts together to form ammonia. 1 volume of nitrogen and 3 volume of hydrogen reacts together to form ammonia. Number 2, it is an exothermic process, means is evolved during the process. 3rd, formation of ammonia is accompanied by decrease in volume because 4 volume of reactant reacts to form 2 volumes of product. Here we discuss reaction N2 plus 3H2, reversible reaction is 2NH3. 1 volume of nitrogen combines with 3 volume of hydrogen and gives 2 moles of ammonia. Here the value of delta H is equal to minus 93.6 kilojoule per mole. These negative signs indicate that heat is evolved during the reaction, means it is exothermic reaction. Number of moles of reactant is 4, while number of moles of product is 2. So this reaction is accompanied by decrease in volume. Now we study diagram. In this method, at first, nitrogen and hydrogen in the ratio of 1:3 is passed through compressor pump at a pressure of 200 atmosphere. This is sent to a catalytic chamber where we put powdered iron oxide or iron as a catalyst and molybdenum as a promoter. The mixture of nitrogen and hydrogen in the ratio of 1:3 at 200 atmosphere is passed in the catalytic chamber. Reaction takes place between nitrogen and hydrogen and formation of ammonia takes place. Near about 15 to 40% nitrogen and hydrogen get converted into ammonia. The mixture of ammonia and unreacted nitrogen and hydrogen is passed in a next chamber. It is called cooling chamber. In this cooling chamber, ammonia, due to polar nature, liquefies, and here we obtain liquid ammonia, while nitrogen and hydrogen is non-polar in nature. That's why with the help of recirculating pump, it is sent back to the catalytic chamber. Now, second point, we discuss favorable conditions for high yield of ammonia. According to Leach's principle, following are favorable conditions. Number 1, high concentration of nitrogen and hydrogen. If you want more amount of ammonia, then the concentration of nitrogen and hydrogen should be high. Number 2, low temperature. Because this reaction is exothermic in nature, it requires low temperature near about 450 to 500 degrees centigrade is the optimum temperature, and high pressure. In this reaction, number of moles of reactant is 4, while number of moles of product are 2. That's why high pressure is required to facilitate the reaction in forward direction. Third method, what to do and how to do. On an industrial scale, ammonia is manufactured by Haber's process. If we want to prepare ammonia in large scale, industrial scale, then we use the Haber's process. In this process, pure nitrogen and pure and dry hydrogen are taken in ratio of 1:3. Here, pure nitrogen and hydrogen is taken in the ratio of 1:3. The above mixture is passed in chamber containing ferric oxide. This mixture is passed in a catalytic chamber where we take the mixture of iron oxide as a catalyst and molybdenum as a promoter. At 400 to 500 degrees centigrade under the high pressure of 200 atmosphere. The temperature of this reaction is near about 500 degrees centigrade and the pressure is 200 atmosphere. The gas obtained after reaction contains 15 to 40% of is cooled by condenser and liquid ammonia is obtained. Here, the 15 to 40% of ammonia and unreacted nitrogen and hydrogen goes through the condenser where we obtain liquid ammonia. Now, precautions. What are the precautions? Number 1, nitrogen and hydrogen used must be pure and dry, as impurities poison the catalyst. Very first, the nitrogen and hydrogen must be pure, otherwise the catalyst Fe becomes poisoned. Number 2, temperature and pressure should be controlled. We have to control the temperature and pressure. Now, number 5, uses of ammonia. Number 1, liquid ammonia is used in refrigeration. Number 2, aqueous ammonia is used in quantitative as well as qualitative analysis in laboratory, means as a laboratory reagent. Third, in manufacture of nitric acid. And fourth, an important one, in the manufacture of nitrogenous fertilizers like urea and calcium ammonium nitrate, CAN, etc.